Thank you very much, Tom, and thank you to SAICE team for considering this project to be part of and actually to contribute to the SAICE events. Yeah, it's really good to see you. The last time I saw you was after I completed my exam, my BTech exam.
About me.
That was a while ago. Yes.
Sure.
Yeah. But yeah, I did enjoy your lectures, I must say, because I also took time to actually repeat the module. So actually, yeah, good to be with you. But yeah, thank you very much to everyone that has joined this visual site meeting. And for us, it's very exciting. When you look at the rain outside, you think that usually then you call off the meetings. But unfortunately today, everyone needed to come because everything is done virtually. So thank you very much for actually for having or choosing this project. We are really appreciative of the fact that you were part of the SAICE event. And I would like to then welcome everyone that has attended and all the colleagues that have also connected online. We understand that there are also industry colleagues in their hundreds. I've not seen the register there, but I believe that there are many that have connected online who are SAICE and non-SAICE members and who have decided to connect at the comfort of their offices. Welcome. And also to SANRAL management and colleagues who may have connected online, and the site team, WSP and the New England JV team, welcome. Also, as Thomas indicated, I'm also very glad that the institutions of learning are also part of this virtual site meeting. And yeah, maybe I'll just give a brief overview of the entry project, because it is important that we have a context of that corridor before we actually delve into the specific package that we're actually looking at. And the entry corridor, actually, this contract forms part of this ambitious entry corridor upgrade program, which extends between Ipiclute and Pietermaritzburg. That comprises of 13 packages, and the entry corridor, as many of us would know, is the largest and busiest corridor in Africa, connecting Durban Harbour and the South Africa's economic hub, which is Johannesburg. So it is really a backbone for South Africa's economy. So the objectives in terms of having to do the upgrade or undertaking the ambitious project of doing the upgrades on the N3 were actually informed by the increase in traffic, the current challenges with the freight rail. You would know the stat says that over 80% of the freight is actually on the road. So there was then a need to strengthen the Durban to Gauteng corridor infrastructure through the capacity improvement to reduce the congestion or the bottlenecks and then improve the safety as well. So these projects are actually intended to respond to the country's key priorities as well. In our context, which would be infrastructure development and providing decent work and economic growth, and also reducing the inequalities. That we can move to the next slide. So basically, the next slides are just showing us in terms of the mandate that SANRAL has and how we actually go about undertaking this project. The SANRAL's mandate is to actually manage, control, and in our context, to develop the national roads within the framework of government policy. So that is actually what drives SANRAL to undertake these road upgrades. The next slide. So we have SANRAL actually has a long-term strategy which is called Horizon 2030, and which actually defines the 5 business pillars which then serve to integrate the operations and activities across the agency and deliver different forms of value. If you look at these pillars, it's actually roads, provision of roads, and then stakeholder engagement, which is key. You would note at the bottom right hand there, transformation is also being added as part of the pillars, which actually drive SANRAL's business. And then you've got road safety, mobility, and as indicated, transformation. So this is just to rehash what I've indicated in terms of the need for the N3 upgrade. As you can see on the first slide there, we need to connect the Durban port and Gauteng province, which is the economic hub of the country. So you can see the purpose that then the N3 would serve as a backbone in terms of the economy. As you can see the stats in terms of the freight, more than 40% of South Africans' GDP and over 60% South African import and export. So you're looking at what is going through the harbour, and over 80% then goes through the N3 and gets distributed to all the parts of the country. And on the right-hand side, you can see the bottlenecks, which we've indicated, and the congestion on the parts of the N3. And this part of the N3, which is highlighted here, is fairly close to Pietermaritzburg. So it's very close to the package that you are on. So whatever traffic that you see there, it's actually likely that it's also mirrored on our package. And definitely, this is what we do not want to see at the bottom right corner. That was supposed to be a taxi, if you look at it. But yeah, that is how unsafe. Compact taxi. That is how unsafe our roads then have become. And that is basically what the N3 corridor upgrade seeks to address, to actually provide capacity and undo the bottlenecks and also improve the road safety. So these are the packages. As we've indicated, this SANRAL has undertaken an ambitious drive to upgrade the N3 between Ibiklute. As you can see, that is package A, that is Ibiklute. And we've got up to package M, which is in Pietermaritzburg. So package L, which is this project, is actually, as you can see it there, just as you enter Pietermaritzburg, and part of Pietermaritzburg actually is within this package L. Thank you very much. That's it from my side. And again, welcome everyone to SAICE team. Feel at home. Hope we'll all enjoy the experience that will be provided by this site visit.
Over to you, John.
Thank you, Mthedisi, for that very warm welcome and providing some proper context to this presentation in terms of what SANRAL is trying to achieve through this and the market road project. So for everyone that has joined us online, what we have presented on the screen, that's the program for the day. Following SANRAL's welcome, we're going to go right straight into the health and safety shift, and one of our site staff from WSP side, Pobelan Gavanger, will give us that. And I'll take the opportunity to then provide the project overview. That will be followed by the presentation by some of our young graduate engineers on site here. For example, McKune, who's got just over 2 years of experience post-graduation, is going to take us through all the planned road upgrades under this project. And we've got one of our senior structure specialists from WSP, Fred Black, who's going to take us through the bridges aspect of the works. And we've got Skundo, another graduate engineer, 2 years of experience. He's going to take us through the culverts and Bongani, retaining wall structures. Then the contractor will come on board to take us through the capital accommodation plans in as far as this job is concerned. It's a very big project with a lot of impact on local capital accommodation patterns. So the contractor will take us through how we're managing all of that. And then we'll also look at the contract progress. I think what everyone will find interesting is the video that we prepared, the physical progress to date. So I think that you'll find very interesting. And of course, as part of SANRAL's transformation objectives, we've got the contractor participation goals, and the contractor will take us through that particular part of the presentation. And lastly, as part of, again, SANRAL's transformation and development objectives, we have community development projects, and for that we've got PMA. PMA is one of the targeted enterprises under WSP, and they're playing a very meaningful role in this project. And lastly, this whole presentation will be followed by a site visit out to site. We'll take you to specific areas or working areas on site where we believe you'll find what we want to show you interesting and very informative. I think while I'm still on the floor, in terms of the project information, some of this, the client SANRAL has already touched on this, but this is the upgrade of the National Road M3, Section 3 from Gladys Manzi Road to New England Road Interchange. It's here in Pietermaritzburg. The employer is only one, is the South African National Roads Agency, SANRAL. The lead consultant engineers on this project is WSP Group Africa. The contractor is Grinaker-LTA joint venture. We also have a site lab. Worth noting that our site lab was recently SANRAL accredited, just to tell you the quality of service providers that we have on board. The applicable conditions of contract on this particular project is Spirit Conditions of Contract 1999, the Red Book, and the standard specifications. We're still working with the old COTO standard specifications for roads and bridges, not the new COTO, because the tenders went out a while back. The contract value is just north of 1.6 billion, expert CPA and contingencies. And in terms of the total expenditure to date, expert, we're just sitting north of 600 million. The contractor has made some significant progress, and credit to the whole team from SANRAL consultant and the contractor. The contract original duration is sitting at 44 months, including 3 months mobilization period. And currently, we're estimating to complete the project in February 2027, likely to extend beyond that. In terms of the project organogram, right from WSP side, in terms of the site supervision team, it's led by the contract engineer, Peter Pretorius. And I'm assisting Peter as an assistant contracts engineer. My name is John Ramutla from WSP as well. And we are led by our senior resident engineer, Kobus Bawa, and he's leading a formidable, diverse team of young and old engineers.
I don't see any old people here. Maybe one.
If you could see in the room, you'll see how diverse the teams are. It's young people, mostly young engineers. They're learning a lot, and fortunate enough to have very experienced engineers who are willing to share the information and the experience, which is very, very important for the industry. In terms of the contractors organogram, that's, as is you can see, it's quite comprehensive. There've been some few changes recently, but that's the latest organogram that we have approved. It's quite a big team. Marisa, I think we've got in terms of the students that we have, that we're training, about over 86 students on this program. Don't ask me how we are accommodating all of those. We've got a very sophisticated training development program inside. So great stuff. In terms of our people, this is the team that is responsible for the successful execution of this project. At the top left, we've got the Grinaker-LTA team in their blue and gray colors. And top right there, you've got the WSP team. And right at the back there, you can see Kobus leading that whole team there. And our team is actually quite an active team. We take our health very seriously.
And they're all here in the all 21.
Because it's raining outside, but also it's good to be here. And there at the bottom there, we're at SANRAL offices in the early days of the project with some of our project team members there. Okay.
And the bottom left, they have to run to work.
Yeah. Tom, with your permission, at this point, what we would like to do, safety on this side it's of utmost importance. So we take safety very seriously. Unfortunately, our client equally values safety. And as a result, we have a health and safety moment share that we have prepared. And for that, I'm going to ask Public Governor to take us through this section of the presentation. Thank you.
Thank you, John. It's a real privilege to share the health and safety share. It was something that happened personally to me, and it's such a privilege to share this incident that took place last year on the 21st of November 2024. It was a Thursday evening. I had to go to the asphalt plant, and the plant is situated about 15 kilometers from the site on the R33. It's a gravel road off the main road that is about plus minus 3 kilometers. As I leave home, I stay in close proximity to the plant, about 5 kilometers, and I was on my way to the plant, and it started to rain. I was not perturbed by the rain because to me it was just normal rain, and I went to the plant on the gravel road, and it was fine. I arrived at the plant, and thereafter it started to rain. It started to rain quite heavy. Eventually, around about 7 o'clock in the evening, I got notification that, listen, due to the rain, the contract has been cancelled. We want to asphalt, so I don't have to worry. And it started to rain quite heavy, and I decided to sit out the rain, and I remained in my car. And eventually, around about 7:30, I realized that the storm was starting to subside. And I realized that, listen, it would be an ideal opportunity just to go back home, because since nothing was taking place. And as I started to drive on the gravel road, heading towards the main road, it started to rain. And suddenly I found myself in a sudden flash storm that suddenly sent torrents of water across the road and sweeping my car away from the road. It was something unbelievable, because I was in a dilemma, and I realized suddenly now that I'm in serious trouble. The car switched off, and it was absolutely dark. And I realized that I've got to do something. I'm absolutely in danger. And the first thought that came to mind is, listen, the car is drifting and the car is bobbing away. And I realized that, listen, I've got to get out of this car. I've got to do everything to get out of this car, because I'm going to find myself in great danger if I do not. And I put my hand to the water was rising. The car is drifting away. The water is rising, and I somehow see the water at the side mirror. That's how dangerous it was. I eventually put my hand to the door and opened the door, and the door suddenly opened, and that is the miracle that unfolded, because I realized that, listen, when I started to drive away from the plant, the car automatically locks. And suddenly now, while in this dilemma, the car door opened, and I got out of the car, and I realized that the water was really to my shoulder, and I started to wade across this, sort of road that is no more the road. It's actually a raging river, and it was totally dark, and I could see nothing. But the intermittent flashes of lightning allowed me in that brief moment to see part of the road, which was 50 kilometers away. Not 50 kilometers, but 50 meters away.
It's a good vision.
My way to the top of the road. I had to walk another at least half a kilometer to the top of the road. And I'm deciding now, listen, I need to get help, because I'm like 5 kilometers from my house. And I don't think anybody's going to stop, and help me, because it's a massive storm. The storm is just intensifying. There's flashes of lightning and thunder, and I'm drenched as well. And I tried to flag a few people down, and unfortunately no one stopped. And eventually a kind gentleman did stop, and I told him the problem, and he allowed me. He told me to someone that stays close by. I eventually got home and explained to my wife that the first thing she asked me, "Where's the car?" That brought me home. And eventually, I explained to her the situation, and she was quite happy to see me all in one piece. I got some help, and I eventually came back to the site where the car was washed away. And when I came back to the site, I want to thank WSP, Willie Detroit, did all the necessary activations. And when I got back to the site, all the emergency services were there, and the fire people were there, the rescue were there, the ambulance, the police as well. And the local community also came to assist, because the word went out that, listen, a car was washed away and the driver was in trouble, and they were searching for the driver. But in the car, there was no driver, and they were looking. And eventually, when I came there and I went to the rescue services, and I mentioned to them, listen, you don't have to look for the driver, I'm the driver. And I can tell you, they were very relieved. They were absolutely relieved, and got all the hugs as well there. I want to thank WSP for their professional services. Apart from engineering, they're full of compassion as well. And I know Willie said to me, he says, Barlin for short, he says, Barlin, you need to take some swimming lessons. Willie, thank you for that advice. And to my PPE, I've also added a life jacket, Willie. Eventually, something comes to mind regarding health and safety. And although this incident will resonate with me for a very long time, I don't look at it as a negative thing. I look at it as a positive, because a lot of positives came after that. When it comes to safety measures, I'm very resolute with safety measures. I look at safety issues now with a greater determination. Every day that I come to work and I do site visits, safety is a real concern. If you take safety for granted, you can be in serious trouble. And when I look at the safety issues, I do have a very positive attitude towards safety issues, and I've allowed those safety issues to be embedded in my way of work. And every day when I do something, I'm always looking out, and I'm always striving to improve safety things that I could adopt as well. So it was quite an experience. And if I had to put a word, if I had to title this health and safety shift, I would say surviving nature's fury through the grace of God, because God is faithful. Thank you. Thank you.
I thought you were going to tell us that the principle is all WSP staff must have 4x4s.
Thank you, Pablo, for that health and safety. We've heard it several times now, but every time when we hear it, it's like we're hearing it for the first time. Because, there's a lot that can be said about that. In the interest of time, we'll then move along. We will now be looking at the project overview. I'm sure you're tired of hearing from me now, so I'll do the next few slides, then I'll hand over to my team, who's going to take you through much more interesting part of the presentation. Just again, perhaps maybe what you're looking at on the screen now is the project locality map. And maybe just to reiterate Sandro's point earlier on, that the project, in terms of the project limits, it's starting at Ladies Mansi Road, or what they call Mbarei Road, and it goes up until New England Road Interchange, and it's located here in Pietermaritzburg. And I think what's important to note is that this project, it forms part of the largest strategic infrastructure projects that are aimed at improving road capacity and safety of the N3 corridor. And in particular, while we have this picture here before us, it's important to note that there are a number of communities that will be positively impacted by the developments of this particular section of the corridor. And these areas include, but not limited to, Hayfields, Scottsville, Bondeni, Epworth, the Meadows, Cleland, and Belleville. Looking specifically now at the actual high-level scope overview.
Let's go back to the drawing, John.
Yeah.
But can you just orientate the viewers? So to the left of the drawing is towards Durban. And then to the right, obviously, is towards Joburg.
Yes, yes, yes.
You've got Mkondeni at the top left-hand quadrant. And the SANRAL offices, for those of you who visit SANRAL, are actually sort of just slightly hidden by the map, the insert.
Yeah.
Adam is just busy showing you where the cursor is now is Hayfields. And I think the place that you've demolished half the people's houses is called Meadows. So there we are, it says the Meadows.
Yeah.
I'm sure they weren't pleased when you came with your dozers to knock their houses down. Okay, just to orientate people. So Durban to the left, Johannesburg to the right. Thank you, John.
Okay, thank you, John, for that. I appreciate. Just again, looking at the sort of high-level scope, the team will break down in further details. At main, if I had to summarize the scope of this project in 7 points, first we'll say that the existing N3 main line will have to be widened at approximately the same levels and grades as existing lanes. There will also be upgrading of existing interchanges to cater for traffic growth, and obviously some of the existing bridges in general terms, when it comes to the widening, will entail the demolition and replacement of existing structures with new wider bridges that will be set at similar elevations to existing structures. Because of the widening of the M3, there are 4 identified culverts that will have to be extended to accommodate the widening. And there will also be the rehabilitation and upgrading of the existing pavements and some of the construction of new pavement layers. Now, in addition, everyone listening, is that as you could have seen on the locality map, the planned construction works are not limited to the N3 main line, but there are also some roads that are falling under the municipal jurisdiction that will benefit from the planned upgrade of the N3. And these roads include Market Road, Allan Burton, Cleveland Road, Blackbella Road, Washington Road, and Betty's Manzi Road. And perhaps on this same line of thinking, they are also number 2 in particular identified community development projects. These are projects that are located a bit further away from the N3, as you'll see further down the presentation. And these projects are aimed at providing further development of public infrastructure to the communities. But the team will speak to that in a lot more detail later on. And my last slide of the presentation looks at high level, where are we sitting from in terms of the progress to date. So obviously, we're in construction, the design has been completed to 100%. The tender, obviously, as well, is at 100% duration. We're sitting at 45% completion of the 44 months original duration. Construction, 39% in terms of physical progress, and expenditure is sitting just under 40%. I'm not going to go through all of the details on the entire slide. I'm sure the presentation will be shared and you can just go through that. At this point of the presentation, as I step away, Tom, there is the first video of the 2 that we're going to show. This is a video, it's a simulation model of the design. There have been further updates of the design model. So if you are familiar with the scope of the project, you might say, hey, John, what I'm seeing on the model is not exactly what is actually happening on site. That's because there've been further updating of the design. Thank you. I'm going to hand over now to my colleague, Abdullah Puni, to take us through the.
You can just talk from there. Eh?
Good morning, everyone. I'm Abdullah McKune. I was a graduate engineer for WSP. Thank you, John, for the high-level overview of the project. I will take it from here. Looking at road upgrades as designed. From our scope of work, there is a total of 6 roads to be upgraded. It's Washington Road, Market Road, Murray Road, and Cleveland Road, and Allen Patton and Blackwood Road, and Entry Road. The operational improvement of entry southbound and northbound. Widening consists of widening of entry main line from 2 lanes to 4 lanes northbound, and from 2 lanes to 3 lanes southbound. And construction of the new diverging diamond interchange at Market Road. And interchange improvement to ramps and crossroads, and also including structures. Looking at the pavement improvement, a full construction of the entry pavement layers will be done with a CRCP base, and the extension of the new roads is approximately 120,000 square meters. Market Road. The operational improvement of Market Road consists of entry to Van Eck, increasing numbers of lanes from 1 and 2 lanes to 3 lanes per direction, and also from Van Eck to R103, increasing the numbers of lanes from 1 to 2 per direction. And looking at the improvement of pavement, a reconstruction of the existing pavement and the new pavement will be done. Murray Road and Cleveland Road. The operational improvement of Murray Road consists of there will be a demolition and a reconstruction of the bridge, which this will lead to a vertical alignment regrade due to the new bridge being done. And new 4-lane bridge for future upgrades of Murray Road, and also a minor horizontal alignment adjustment to accommodate for future 4 lanes and configuration for roads and bridges. A new signalized intersection to align with future extension of Cleveland Road south of Murray Road. And looking at the pavement improvement, a construction of a new pavement layers will be done. Blackborough Road. The operational improvement of Blackborough Road consists of the demolition and reconstruction of a new bridge, which this will also cause a vertical alignment regrade due to the new roads being constructed, and 2 3.5 meters lanes per direction with a 3.5 right turn, and a 2 pedestrian walkway will also be constructed on the north side. Okay, and also there will be a construction of a new traffic circle to ensure a full access to the service of the station is maintained. Looking at the pavement improvement, a new construction of the pavement layers will be done, and the total length of the new road is 300 meters and 3,640 square meters. Moving to Washington Road. The operational improvement of Washington Road consists of the upgrade of Washington Road from the Market Interchange to Portland Road. R103 will be upgraded to a 4-lane single carriage with a painted median. The pedestrian and cycling will be constructed on either side of the road, and the upgrade of the intersection with Murray Road and Portland Road to accommodate an additional right turn and left turn. Looking at the pavement improvement, a reconstruction of the existing pavement layers would be done. New pavement at widening for an additional lanes will be constructed, and a total length of the road is approximately 1.7 kilometers. Okay, this slide shows an overview of our road upgrades, which consist of 6 roads. Okay, looking at the slide, the road that is highlighted with red, it's Market Road and Washington Road. And the pavement layers is as follows. The blue road. A field which is a G7, follow up by a selected layer which is 150 millimeter C4, followed by another 150 millimeter C4 selected layer, and 180 millimeter bitumen treated base. And on top of a bitumen treated base, we will also have a EA2 mixed wearing course. The A2 mixed wearing course. Okay, looking at our presentation, the red road that is highlighted with red, it's our main entry road, and our pavement layers is as follows. An in situ or a G7 fill, followed by a 600 millimeter selected layers, which are C3s stabilized, and our base is a 250 millimeter CRCP continuous reinforced concrete pavement, and on top we have a 45 bitumen rubber. And the roads that are highlighted with green, it's Cleland Road and Murray Road, and the pavement layers are as follow. A G7 fill and a selected layer of a C4 150 millimeters, and our base, which will be a bitumen treated base, which is 80 millimeters. And on top of our base, we have a 45 AE2 mixed wearing course. So this brings me to my end of my presentation, and the structural sim will take it from here.
Well, thanks, Avrila. Just introduce myself. My name is Craig Black. I'm a structural engineer from WSP. So I'm just going to do a brief overview of the bridges that were mentioned before. Yeah, so this is just an image of the site plan, just indicating the bridge locations and the culvert locations. So Sfundo will touch on the culverts once I'm done. So you can see the bridges in yellow. So there's in total, there's 7 bridges. Basically spread across the site. I think this is just giving you a general overview. I think if you go to the next table, we'll just show basically what's happening, and then we'll get into some pictures. So of the 7 bridges, 2 of them are new, are greenfields construction, essentially. That's BO558 and BO559. 4 of them are existing structures that will be completely demolished and reconstructed to accommodate the widening of the N3. And then 1 of them is a widening only, and that's the rail bridge, which is quite far progressed in construction. Okay, so I'll just go through each bridge one by one and just talk to the general design and the progress of where it's currently sitting on site. So this is Murray Road Overpass. So this is one of the bridges that will be demolished. So in terms of current work progress, They're currently busy with the test pile, which I believe is quite well progressed at the moment. There will be ultrasonic logging inside the test pile. They haven't started with any excavation works or any construction works as yet on this bridge. So if you look at the design cross section, so in general on these bridges we use twin span bridges or spine bridges, either twin span or 3 spans. And this will be a post-tension bridge that's a double span going over the N3. So as you can see on the cross section, what will be constructed now is just 2 of the spans. And as part of this contract, we will construct a segment of the pier and abutment bases to allow for future widening. So that's indicated on the dashed lines on the right-hand side. So just for any future event where the bridge needs to be widened. Okay, so I thought I'll just indicate the typical pier design that we've used throughout the project. You'll see when we go to site just now, this is typically what we've done to the pier. So this will be unique to this contract. And it follows through on all the bridges. It's sort of like a half moon shape on the piers, which actually came out and it's looking really, really nice. Everyone seems to like it. So yeah. Everyone keeps asking me what the design philosophy is, what the mentality is, and we just thought it looked cool. So,
So there's no structural value, it just looks cool.
yeah. So we don't need to overcomplicate that. Okay, this is Bureau 557 A and B. So this is a current progress photo on the right-hand side. This is the main interchange bridge passing over the N3. So on the left-hand side, you can see a good elevation photo of the existing structure. So that structure is currently still in place. If you look at the drone photo, you can see the structure in the background. So what is happening with this bridge? This is a 4-span spine bridge constructed in half widths. So currently they're busy with the first half of the bridge. Once this is complete, this bridge will be open to traffic and the existing structure will be demolished, allowing for the construction of the second half of the bridge. This is also a 4-span post-tension twin span deck, and essentially each deck is independent of each other. So it's basically a copy paste of the 2 structures. Okay, this is the only bridge widening that we have on the project. So this is a rail bridge passing over a Transnet line. So this structure was widened quite recently. You can see current progress photo on the bottom right. This is on Market Road. So there was quite a number of challenges with this structure, which I think Andries is quite well aware of, and I'm sure the owner is the contractor. But there was clearance issues with the rail. The railway line had to be shut down temporarily to allow for the beams to be lifted into place. There was quite a number of challenges, particularly with construction, as you couldn't shut down the rail for a long period of time. So there had to be temporary boarding erected in front of the abutments to provide a safe working area, which was actually very small. So this is quite a challenging structure. Okay, this is Market Road over Cleanan Road. So this is one of the Greenfields bridges that's quite well progressed. So you can see some drone photos on the right-hand side. I believe they are now finished with the parapets, as Swindle has told me. So this will, if you look at the bottom drone photo, it will lead up to Market Road, the interchange bridge that we're talking about. So the contractor is currently busy with the bulk earthworks on the approaches. So this is also a very similar design. It's a 3-span bridge with quite a dramatic super elevation and longitudinal fall, as you can see on the elevation. Okay, this is another bridge which forms part of the Market Road interchange. So this is BO 558. We call it the CBD bridge, that takes you into the CBD if you take the ramp, essentially. So this is a curved structure which will form part of the interchange, also a twin span bridge. And as you can see, there's some progress photos on the right-hand side. Once the structure is done, there'll be an off-ramp off the N3 passing underneath it. Okay, then this is BO 560, which is the Adam Payton Drive underpass, or we call it Epworth. So the Epworth structure is the existing structure, which you can see in the top right of the screen, which has actually since been demolished. So this structure was for a number of years, it was standing with, as you can see in the middle, temporary structural steel props. There was quite a number of issues with the structure. There was some uplift on the back spans as well. So this had to be completely demolished. And what we're doing here to replace it is essentially a portal underpass, or sort of a tunnel, but it is a bridge for all in technical terms, but it will pass underneath the N3. And on the left, you can see a design cross section and then a plan view below it, showing the curvature of the portal structure. Okay, and then lastly, this is our flagship bridge on this project. I suppose you could say this is Blackborough Overpass. So again, the structure on the existing structure, which no work has been done at this bridge at this point in time, that structure will be demolished to accommodate the N3 widening. And what we've designed here is a single span network arch structure. So it will span the full, I believe it's 60 meters over the dual carriageway. So it's a structural steel arch with hanger cables. So it's called a network arch. It's the Blackborough Overpass.
Thanks, Craig.
Yeah, I believe that's it.
Thank you so much, Craig. Thank you so much, John, for the opportunity. I'm Sfundo Tubane, and I'm presenting over the culverts. In our scope of works, we have 4 culverts, 3 existing. They will be extended or upgraded, and 1 was already demolished, and it was a new structure. Just go down. Starting off with C0731, Pietermaritzburg. We call this Clean Road Culvert. It was an existing 3-cell structure, and now it has been upgraded to a 4-cell, 27-meter long structure. So this one, we found some issues on soft material that we found on the foundation, but we proposed hard rock up until to the design funding level. Then that's why we started our slab. Then the construction of this culvert progressed very well. We are now waiting for an upgraded clean road on top of it, and we are confident enough that it will serve its purpose. Moving down to C9506, the top on the left is an existing structure. It's a small structure, this one. Current in progress on your bottom left is clearing and grabbing of the structure. So in this one, we're gonna extend on both inlets and outlets. 2 meters on the inlet, and it's 1 meter on the outlet. So that's why I'm saying the small structure. But on the right-hand side of the structure, if you can see the cross section there, we're gonna add a 2.75 by 2.9 meter cell. Then yeah, that's it about this structure. Let's move down. Second last, C9505, Pietermaritzburg again, and the Allen Pitting. This one was a 4-cell structure, and again, it's still a 4-cell structure. It was upgraded or extended both inlet and outlet. Outlet, it was extended by 6.85 meters. In the inlet, so this picture under current progress demonstrates the inlets of the structure. It was extended by 3.7 meters. I think we have saved some cash on that one because we did not construct downstand beams on that one, on both aprons, inlets and outlets, because we found hard rock. So those apron slabs are being supported by hard rock. So we drilled and doweled Y16 bars. Then we constructed our aprons. So we are very confident enough again, those aprons will never move.
They better not.
Hope not.
Interesting one. This one is a long one. C1021A and Pietermaritzburg. So this one is accommodating entry ramps ramp A and ramp E. Ramp A is our inlet. So this picture on the top, the bottom left is ramp A, the inlet of our structure. Then you can't see the outlet. The outlet is 64 meters long. So we're gonna extend the structure by 64 meters long. The inlet is being extended by 32 meters long. So approximately 1,600 meters of concrete, meter cubes concrete is in the structure. Over 300 tons of high strength steel is gonna be used in the structure. So it's a very big culvert amongst the 4 culverts. Yeah, we have some issues with this one, so don't move, please.
Okay.
We have some issues on this one, environmental issues. I don't know what is happening on the inlet in the site, but the industries are affecting our stream. One day you wake up, there's gray water, there's black water, but I think the contractors, environmental officers are working very hard to assist us in this one. I'm also part of the team. Water diversion again. When there is much rainfall, it's a big problem for us again. But for now, we seem to be winning on water diversion. On this ramp that you are seeing now, we encountered the problem that has required us to remove the whole cast blinding because of the type of the material that was used, underneath material that was used in the blinding. So it's retained water, and then the blinding had defects, so it has some cracks. So we thought of a possible solution. We removed the whole blinding layer. We also removed the underlying material. Then we put in the 19 millimeter stones on the whole ramp. Then we put in the beading material, which is very good for, we currently use this for mostly in our culverts, which is very good for drainage. Then we casted our blinding again. So I think the 19 millimeter stone and beading material did help. And then our foundation was put. We didn't see any water seeping out of the blinding or on the base. So yeah, on the outlet, we got a geotechnical engineer who proposed we need to remove the material there up to 5 meters because we found soft material. So we're going to remove 5 meters up to hard rock. So you assume that we're going to have hard rock up to 5 meters. So we're going to remove this this material. Then that's how we're going to start our foundation. Yeah, that was it. That was an overview of my babies. I'm very, very happy to be part of these structures. I really appreciate the opportunity. Thanks.
Thanks. Okay, can you take us through the thing of strategy?
My name is Bongan Dalaze. I'm an RE for Bridges and Structures. I'll be taking you through the retaining walls on this project. Okay, on the screen you can see this is an overview of the retaining wall structures that we've got. We've got MSC wall 3 on the clean loop, and then MSC wall number 4 and number 5, which are adjacent.
Here's wall number 1 and 2.
I'll talk about that. So wall 4 and 5, which are adjacent to bridge 558, which is the paved bridge that Craig mentioned. And then we've got composite soil mill on the north and southbound next to Black Barrow Bridge, which is bridge B0561. I'll be using mostly the bridge numbers to identify the structures. And then, okay, for wall number 1 and 2, they were excluded from this presentation because they are low-fill stone, and the scope of work is going to be done sometime next year. So, but they are along Cleveland Road. Yes. Okay. We'll move on to that. Okay. I'll start by the mechanical stabilized earth walls, which I mentioned that there are 3, 4, and 5. Currently, we're working on retaining wall number 5, which is on the Cleveland loop. So just to describe what it is, basically mechanical stabilized earth wall is a genetic term that is used that include reinforced soils, which in this case, we have reinforced soils using the parawebs. And then it includes also the facings, like as you can see, some concrete structure there. Normally they are called panels, concrete panels, but there are different materials that can be used. But on this particular project, we are using the concrete panels. And then below that table is the summary details of the MSC walls, which we are currently doing. Just a brief summary for retaining wall number 3, which is adjacent to B0558. The wall length is going to be about 264. Wall 5, sorry, and then wall 4, 24 meters, and then the retaining wall 3 is about 186. And the other summaries entails the number of concrete panels that are used, and then the surface area of the wall, and the volume of fill that is going to be used, which is G7 material, and then the length of the reinforcing strips that are used. And currently on that particular wall number 3, sorry, there's an interchange there, but the percentage progress of the wall that we're currently working on, which is number 3, is 85%. And I will just zoom in on that particular wall. Can you move on to the next slide, please? So this is below, there are 2 pictures of this particular wall, which is a curved wall, which is under construction. And the length of this wall is 186 and it consists of 702 panels. So this wall is going to reach a maximum height of about 10.48 meters towards as we approach the Cleland Bridge that Craig mentioned. And as I've mentioned, that we have reinforced the soil, the G7, with paraweb E2E-50 to ensure stability and efficient load transfer. So this, okay. And then the challenges that we've encountered on this particular structure is achieving a proper alignment and maintaining a consistent gaps between the panels. As you can see, it's a curved structure. So putting in these panels together is a bit of a challenge to maintain a consistent gap between them. And then the second challenge that we've had, because we started constructing this wall last year, is the adverse weather patterns. PMB weather, we can experience 4 weather patterns within a day. It's hot in the morning, at 10 it starts raining, and then later in the afternoon it's cold, and then in the evening, maybe it's a storm or whatever the case may be. And then, just to mention also, maybe one might ask why a mechanically stabilized earth wall here instead of a field, natural field like some other sections. So next to this road, next to this structure, there's a stream, and there are hydrological studies that were carried out, and as a result, a buffer line was introduced. So we couldn't use a natural field. So to avoid this road being washed away, imagine all the water, all the cars getting washed away. Maybe there's a heavy rain because PMP, then all the water just wash away all the cars and they'll be swimming in the stream. Anyway, next slide. All right, the second type of the retaining structure that we are doing is the composite soil nail wall. This type of a retaining wall is used in geotechnical engineering to stabilize slopes, prevent soil erosion, or support excavation sites. So why is it called a composite soil nail? Because it combines 2 or more material, which is a saltcrete, which is the one that you see on the left-hand side, and soil nails or concrete facing. So the soil nails, like I'm sure you can see those small rectangles. So there's a soil nail, usually it's a reinforcement bar, about 1 meter, depending on the design, 6 meters, 7 meters, 8 meters, whatever the case may be. It's a reinforcement bar, usually Y25 or Y30 in terms of size. And then on the right-hand side, there's a cross-sectional mapping that was done by the geotech. The bottom picture highlighting the different soil strata formation, if I can put it that way. Unfortunately, I cannot see at the bottom there, but the top layer being the red clay, and then second layer is the dolerite, which is mixed. This Can you read for me?
Residual dolerite and sand.
Okay, dolerite and sand, okay. And then there's a section, a typical section of what is going to be done on Challenge 8.460 on the northbound section. So you can see the red clay on top. That is the typical soil nail that is going to be done. Those bars are going to be drilled inside so as to provide stability on the. And then there's also a concrete facet that is going to be constructed as a result after the soilcrete has been done. Okay, can you move on to it? Okay. Okay, from the previous slide, as indicated, we've got Ward 6, which is on the southbound. That is the road to Durban, and then Ward 7, which is on the northbound. Currently, we are constructing southbound, it's under construction, and the wall length is about 690 meters. For Ward 7, it's 306 meters. And then the surface area is 3.6 Ward 6 and 909 Ward 7. And then these are the volume of material that are going to be used in terms of shotcrete, facet wall, and then the tonnage of rebar also, as well as the volume of grout. I'm sure you can see from the screen. And then the picture on the left-hand side is Ward 6, and then on the right-hand side is Ward 7. Ward 7, which our surveyors have been busy setting out that wall. So it's going to be starting soon. Move on to the next slide. Okay, the challenges encountered as far as this composite soil nail is concerned are as follows. As you can see on the left-hand side, the first picture, as they were busy excavating, cavities were found on the soil structure, thereby compelling the contractor to use more shotcrete, shotcrete, so as to level out the surface. And then the second, one of the challenges that we encountered was that while drilling for the anchors, water was gushing out in some of the section. Probably, maybe there was an unidentified service, or maybe some water that underground that is moving there.
Umsunduzi's bulk water supply line.
Yeah,
Not non-revenue water has just been increased.
yeah, probably, yeah. So as a result, we realized that in one anchor, normally we use about 45 liters of grout in one anchor, but the contractor notified us in one of the anchors that was drilled, they were using almost about 300 liters of grout, and there was definitely a problem. That's one of the challenges that we encountered. And then one of the challenges that we encountered was that the failure of the pull-out test carried out due to the red sand, which was not picked up from the previous geotechnical findings. Yeah. As far as the retaining structures are concerned, that's it. Thank you.
The contractor, Maurice, will address with this particular section of the presentation.
Okay. So I'm Maurice Goodman, the project controls manager for the Union Chain. I'll be taking you through the traffic accommodation, which is quite an intense one for those who are on the project, and I think more intense for those who stay around in the area.
Yeah.
Let's go to the first slide. So the way the job is broken down is that it's broken down into stages, stage A and B, and within those stages, there's different phases. There's various phases. Those phases take us from temporary works to permanent works. So in stage A, we have stage A, which is temporary works, and that's basically first to widen the N3 on this N3 southbound carriageway in order to do a stockading or contraflow in the next phase. So it's first to be able to get the traffic from its existing carriageway onto a side carriageway, thus being creating for the contractor to work on the full northbound in its entirety. So stage A is predominantly for the temporary works. That's one of them. The other temporary works is obviously in our contract. We've got to upgrade the ancillary roads. So I think in total, we have about 9 kilometers of ancillary road works. and that's Murray, Cleveland, Washington, and Market Road, predominantly with a bit on Allen Patton. And those works have to run simultaneous with the Stage A southbound carriageway widening. And that's to make sure that in case there's any accidents along the way when we do the permanent works of the N3, that the alternate roads are at a decent enough level. As you know, Pietermaritzburg being the capital of KZN, but not the capital for the roads. It's a couple driven. And that's one of the things in terms of road maintenance where the contractor is continually attempting to plug holes. I think the more we do pothole maintenance, the more they come up. So if we go into this next slide, so this is just a continuation. As you can see, the dark red on your screen, that is the widening. That's the widening of the existing N3 traffic carriageway, and that then allows the contractor to move that traffic over in Stage B. Next slide. This is further northbound towards the end or towards our construction limits on the north. You'll see on your screen that's the bridge there is Murray as Blackbarrow Bridge. And here it's not as straightforward because you've got the piers of Blackbarrow. So you can't just place two-way traffic under the bridge because you're then only able to do two on one side and then one on the other. So then what happens is you create the widening along the median. And in this heavily biodiverse area with lots of, seems like this is where all the water comes when it rains. We then have to deploy high level stormwater management across the entire site. Water is something that we deal with on a daily basis. I think our contract states the N is equal to 73 days over the 44-month duration, including mobilization. And to date, we've used 93% of the allocated inclement weather days, and we're only about 45% into the project. As you can see, that has the inclement weather has a heavy impact on the productivity and the construction works. You can scroll to the next slide. So this is phase B. So this is now, we've upgraded the majority of the ancillary roads, maintaining two-way traffic on the ancillary roads. And now we want to do the contraflow. We're currently in this phase. We've done our first contraflow at the beginning of this year. There was quite a bit of tweaks. It's when you put something, I'm going to speak to the engineers. When you put on the design, it looks lovely. You can make the lines different colors, make it fancy, and then you go to sites and you're like, oh, this is not working out. The site distance is not enough. The chicane is too steep or too slow. The drivers, it creates its own net effect. If you've ever driven behind a truck in one of Pietermaritzburg's infamous stormy rain downpours, you'll know that it's not a straightforward thing. Especially if you don't have a 4x4 like Formulans, then yeah. So that's the stage that we're currently in. That's Stage B, and this is the middle and to the south part. As you can see, I explained earlier, as you're going under Blackbarrow Bridge, because that's earmarked for the end of the project, so 2026, you then have to bring that traffic under there. You can't keep it on the shoulder.
There's also the temporary deviation.
Yeah. So the temporary deviations, as I said, the idea is that you're always making sure that your alternate routes are of a standard that can house the capacity, the increased capacity, if anything should happen on the N3. I'm quite sure that any road user in Pietermaritzburg does not like the contractor, especially on a Friday, pay weekend. Thursday today even. Traffic's going to be slow. If you're going to Durban, leave early. It's usually about a 45-minute, but it could be 3 hours.
Specifically Washington.
Yeah, so the specific one is the R103 coming down. Those of you who have attempted to do a marathon, you should know this route quite well. Thank yous in order. We've made that road better already. and that goes through from Ashburton all the way down through to Scottsville. That's the alternate route, official alternate route. That's the second one, which is quite well published on the SANDAR websites and all the notifications that go out. And the last one, then I guess it's all including on the R103. That is the designated alternate route for this project, depending on where you live.
Just gonna try and remove this. Is it possible to remove this
I
logo?
think it's still right because it's closed. It's closed. Yeah.
It's gonna follow about it. Okay, I think maybe at this stage of the presentation, to the follow-up speakers, looking at the time, we can try to speed it up. But now, Tom, we're looking at the contract progress, and Marie still want to take us through this as a project.
Yes. So as I said, the project is fairly underway. We're currently working in two major areas of the contractual program. So one is the roadworks, and the other is the structures. And in the roadworks, we're like 46% in, which is on par for the amount of works that's currently planned versus the actual. So you'll see there's some areas on the right-hand side there, stage A1, A2, A4, which are all the widenings that needed to occur in order for the contractor to do the contract flow on the M3, and that's 100%. The market road where Bongani was talking about the beautiful MSC wall, we had a decent 75% there, that's stage A5. I think that's one of, as a contractor, we're very proud of the works being executed on the entire project, but specifically on that area, because it's nice, it's technical work, and it gives our construction engineers good value in terms of what they're getting on this project. Our engineer there is Sipho Maslangu, and he's managing that war, I think, together with WSP in a tremendous fashion. If you go further down along the way, as you see, we saw all the way down to stage 11. Let's go back one, please. And then you see at the bottom there, we've got a few stage Bs that have come into play now that permanent works can commence. Awesome. Structures. Next slide. On the structures, we've completed 100% one culvert, and there's a second culvert line 4 that's 93%. Those are two of Swindo's babies. The balance of the bridges in there, and there's just the team has been phenomenal. I think it's unfair and Bongani that still yet that on the ground interaction between us and them, and we enjoying the interaction there.
And at this stage of the presentation, we're just going to fill up the progress page. I think people will find this interesting.
So that big hole in the ground is part of the market rate interface stuff.
Yeah, I think we can all through that video can see the magnitude of this project and the vastness and the diversities. At which a 2 billion rand Sandow project is executed at. Yeah, I think as Grinaker-LTA, we are really appreciative of the sort of works that the engineers have through their guidance that we're executing and constructing. And I think it's quite pleasing.
Thanks, Maurice. Really appreciate it. Evan will take us through the CPG.
Hi. Hey, greetings everyone. Yeah, so I'm Kevin Durant, I'm the key construction manager on the project. So we have been tasked to implement SANDRAL's CPG policy, which talks to transformation, empowerment, and excellence in the construction industry. So part of my portfolio is to do the development, training of small, medium, and micro enterprises, contractors, as well as the labor, which forms a substantial 30% of the contract. So I'll just take you through firstly to the CPG plan, and we're going to just basically delve onto the tendering process. So prior to commencing official construction work, we go through a mobilization period where we draft a CPG plan that is preliminary, going through the contract documentation, and basically from what we get the packages, we get the timelines, and so we basically then use that as the starting point to start our contract participation process. Once we get on the site, we start our tendering process, and the tendering process will then entail going through the CPG plan, putting on the packages according to the timeframes. Once we get the packages constructed by the quantity surveying and commercial department, we then have a review of it. And then from there, once we are satisfied and we get sign off, we then goes onto advertisement. It gets advertised in the local newspapers, put on the SANDRAL ESSD portal. We inform the PLC so that they can inform contractors. We also got a database of contractors that put in their application where we send out emails. And so what we then tend to do is go out on the tender process, and then we follow the process that we similarly done in the construction industry, where you have your tendering, your clarification, and then we've got an external procurement company due to the value of the project that does an independent procurement process. And so once the tender documents are submitted to the company, they will go out to the advertisement, and then we only receive the tenders after the tender closing and the adjudication. Once the adjudication is done, we go through it and then we submit it to review to all the stakeholders. And once that is approved, we then look at the appointments. Prior to appointments, we might have to do some sort of negotiation according to some of the policies to ensure that the contractors come to within the rates, the highest calling contractor come to within the rates that is acceptable. But that isn't all the tendering process, so we can get to the next slide. Not that you're rushing for time here. So this is basically a spreadsheet of where we are. We've got targeted labor and targeted enterprises. And this is, you can see that the tender target percentage is what we have to achieve. We see that CPG total target expenditure is the value of that percentage. And then we, on the achievement section, we see what the percentage expenditure to date is, what the percentage of the CPG estimated total expenditure, and we see the amount. So currently, as we look at it, in terms of the CPG spend that we are reporting on, we are 12.62% of the targeted labor, and on the targeted enterprises, we are at 16.4%. Immediately to the left of that, you see that 3.06% and 11.94%. Those are a percentage of the total contract value, which is the 2 billion rand that Maryse has spoken about. And as we progress to the next slide. Okay, so this is the summary of the packages that have gone out. We've got a plan, like I spoke to about the CPG plan, which talks about like grades 1 and 2, we are targeting 45, 3s and 4s, 23, 5 to 7, 20s, and currently what we have got awarded. As the job now starts to become more streamlined and more areas open up, that will start to increase substantially. Also within the policy, we've got to target certain enterprises. And so we've got the enterprises that are in terms of the CPG plan, and some of the policies are women, youth, and the disabled. We also got military veteran-owned companies. So this is what we have targeted on the CPG plan, where we have 9 movement entities. We're currently sitting at 8. The youth-owned, we have 18. We're currently at 2. But that said, quite a lot of the women-owned entities are also youth-owned entities as well. So in actuality, that number is a bit higher in terms of the targeting of the youth. But because we don't want to sort of double dip, that's the reason we put it in. And then,
So it's a good time to be young and female in the Sandal spheres.
and then we've got disabled companies that are on board, and as well as the military veterans. So go to the next slide. So we've also got labor that we need to employ. That 10% of our spend has got to come from the labor. So we're basically looking at of our CPG value of 650 million, where 488 million is made of the target enterprises, and 10%, which is 162 million, is made out of labor. This basically pie chart gives you a breakdown of the different wards and where the labor basically comes from. So yeah, so we've been pretty transparent on what we're doing, and we need to be inclusive of all wards. Yeah, so even so, if you can just go to the next. So we also participate into the training and skills development. This particular portion talks about the contract skills development goal, which according to the document is 0.25% of the contract value. This has proved to be so successful on our project that we've been awarded a phase 2 on this as well. So going back on phase 1, we've got under the contract skills development goal, we've got categories called method 1, method 2, method 3, and method 4. The method 1 are basically your general workers. Method 2 are the old apprentices from the apprentice boards. And those are from the TVET colleges. Then we've got the P1 and P2 students that come from the technical. And then we've got the method 4, which are graduates. So people that are working towards a professional accreditation, like the SACP, CMP, EXA. And so we also help to push them towards that goal by taking them through the process to get that accreditation. Under phase 2, we are also that have now been awarded to us. We are looking at training a total of 240 candidates, in addition to phase 1, which was 61. So that will basically take us to in excess of 300 candidates. And yeah, so the thing is proving to be highly popular. This PSDG is not just simply training, but it is also the development. It also takes into consideration the background of individuals, the previous experiences, what makes them as individuals, the mystery of the person. So everything gets identified, and they also get help from social ills that they may have experienced, sort of abuse. There's mentors, there's guidance counselors. So it's a pretty comprehensive and commendable project that Sandal has been rolling out on this.
I think we maybe want to just take this opportunity for those of our viewers who are currently at DUT or MUT, that you guys can go through to the administration department. Those of you who are doing your P1 or P2, there are several of these CSDG along the entire corridor. So if you're needing your P1 or P2, or you are a recent graduate, then the systems go through to the university. And if your name is on that database, then you hold yourself in good stead to come through through the ranks. Yeah, so I think that's one of the things we just want to highlight for the future packages as well, that is the system to be able to get onto these projects through the CSDG program.
Yeah, it is still line after this as well. Okay, so these are some of the pictures of where our trainees are basically working. These are like the TVET students that you'll see that are doing the concrete vibration. They're doing the testing on the concrete cubes, reinforcing. Yeah, later next question. Okay. Okay, so that's me for a while. It's over extra time, but I was trying to rush through it.
I think Kevin's quite modest in the fact that one of the things we want to highlight is that for the CPG to be a success, and which it is on this project, you've got to have a serious mentoring approach to the CPG subcontractors, from especially grade level 1s and 2s to CIDB 1s and 2s, whereby you're bringing guys in and you're teaching them how to labor, teaching them how to do the paving. They might have 1 or 2 skilled labor, but the majority of their labor is not skilled. It's general labor, it's guys who have been working at the local stores or who haven't been working at all. And so that Kevin quite modestly, he is very intensive on this project. It's very intensive in terms of not only from the lower level CIDB 1s and 2s, but even to the 3s and 4s, who maybe have had the opportunity to generate the spend, but they don't know CCS. As a contractor, that's our, I guess, the equivalent of the consultant's AutoCAD or civil designer. So CCS is the software that most contractors, I don't think there's a contractor of a good grade that doesn't use that for costing, for planning purposes, to double check their revenue versus their allowables. And that's also at that level where Grinaker assists the CPG subcontractors in terms of their growth and development. And that's what's making the success of the CPGs on this particular package.
Absolutely. And perhaps maybe as we introduce the next section of the presentation, really in terms of all these training programs, development of subcontractors, creation of opportunities for local labor, credit to our client Sandra that is really taking this very seriously, understanding the economic climate in this country. And so it's a pleasure to be guided by client in those efforts. With that being said, the last section of the presentation is the community development project. And here I just want to note that the consultant that has done the designs for this CD project is a targeted enterprise under the main consultant. So as part of the development process carried by Sandra, we've got our target enterprises that are doing meaningful work on this project, doing real design work. And yeah, pleasure to introduce here.
Good morning, colleagues. My name is Siabo Manyati from PMA Consulting. So Central identified 2 projects for CD. The first one is improvement on Snatting River Bridge, and the second one will be upgrading of a low-level causeway at Tulas. So taking you through to the Snatting River Bridge. The picture on the right is the current condition of the existing bridge. As you can see that the bridge currently is not in very good condition, and there's some swelling involved, and also you can see that the headways are a bit loose. But the main problem in this bridge is the sidewalk. Currently, there are 2 sidewalks on both sides, and those sidewalks they are both reduced from 1 meters to 0.5 meters. That was done to cater the services. Okay, the scope of works in this project, there will be some minor earthworks. We'll be conducting the new surface sidewalk that will start from an intersection on the right side of the bridge. It goes straight down. There's a taxi rank down the road. Also, there'll be lengthening of the existing culverts. That will be improving the stormwater drainage in this area. The improvements will also include cleaning and clearing the existing open drainages and also the structures and outlets. And we'll be erecting road signs and some road marking. So the structural works that will be done on this bridge. There will be some temporary works for accessories and working platforms. And also, we'll be repairing the existing bridge structure. The new pedestrian steel bridge or cantilever sidewalk will be introduced, which will be on this visible sidewalk of the bridge. And also the services will be relocated to underneath the bridge. So that will mean now the pedestrian will have 2 options to walk. The new there will be a new sidewalk on the left, and also the existing one. This is 1 meter. Will take the existing services underneath the bridge, and also that 1 meter sidewalk will also be used as a walkway. So these are first sections. The first one, top left, we have the sidewalk. That should be 220 meters, starting from the bridge going to the next one. And bottom is the layout. The layout of the proposed state bridge will continue sidewalk. And this is the cross section and how it will look like. As you can see at the bottom, that's where the services will go through across the bridge. Okay, the second project now, we'll be upgrading the existing causeway along the Woodhouse Road. The scope of works.
It is the causeway that goes to Sabantu.
Yes. The scope of works will be realigning the road over the Msubizi River, and also will reconfigure the both intersection, and also intersection that is also going to the left side. Will be the new road. It will be 6 meter wide, will be surfaced, and also because the road will be realigned. This means there should be a new construction of project infrastructure. Okay, going to the structural works. The temporary works will be some accesses and also working platforms. The new bridge to be a three-span river bridge. It will be 11.1 meter wide. And it will be 75 meters in length. It means it's been 25. Also, this the structural works will also put in some cable works to protect the embankments. And also, once the project is done, we'll demolish the existing causeway. All the services will be allocated to the new bridge. Yeah.
As a new bridge going upstream or downstream of the existing bridge?
It will go upstream.
Upstream.
Yeah, the project challenges is to try and maintain the access as long as possible while we're doing the construction of the bridge. So since the bridge will be upstream, I think we'll be able to work do the whole structure, and then the existing bridge will be used as the roads. Okay, the project benefits will provide a safer crossing for the Msubizi River, since the West reported several drownings in this area. So also it's improve the road capacity in this area, because this route it can be used as an alternative route coming from the entry going to the to Sobantu and the surrounding areas. Right. So these are typical cross section. The first one is typical cross section of the approaches, and then the bottom one is the typical cross section of the deck. Thank you.
And that brings us to the end, John. Thank you so much.
Oh no, thank you very much. Let's just have a quick look at. There are quite a few comments in the chat, but I think the questions perhaps are more appropriate for this session. Let me just go and find them once I've got all these note takers out the way. Takalani and their note takers. Yeah, there was a question, and you've answered it, John, that the presentation. Yeah, we need the presentation in any case to do the CPD validation. and then I will share a PDF. If you can send me 2 slides per view is the easiest. So that's a little bit more difficult for people to steal your in content. And then I'll share that with all those that have been in attendance via email. The next one was, note takers are a real pain in the butt. Gift has given you a lot of guidance and instruction as the consulting team. I don't know if he works for the client, but he's telling you to check with Saws on the status of the weather. He has a question though. Did SANRAL include a maintenance period and its budget in the project? If not, how are they going to maintain this project and by whom? I don't think our modern contracting system allows for post-construction. It's a normal 12-month window post the end of the project. But Dutch system is a 20-year maintenance period on the contractor's head, and if anything goes wrong in 20 years, they have to fix it. But of course, that pushes the price up. But I would assume the answer is no.
No, yeah, it's no.
So will it go into the normal routine road maintenance package and
yes,
different sections?
After 12 months defects.
Okay, but you heard from Maurice, they've done such a good job, it won't need any maintenance. We'll be watching.
Yeah.
Okay. Which one? Or
Was it?
questions are coming. If you've got a question, Takalani, just go for it.
Saying how long did the design process take from stage 1 to 3? And what are some of the technical challenges that were encountered?
John, I think you're up. Because nobody else is volunteering an answer.
WSP specifically was appointed the detailed design part of the design scope. So all the design phase is part.
The question is when? How long did it take you to get from appointment as the consultant to having a document ready to go to tender?
The detailed design period was about 2 years. So that whole 2 years was to do the design and use construction documentation.
And was there preliminary design by A and other, or did you go straight into final design?
No, we took over the design from.
So there was a preliminary design. And how different is your design implementing now to the preliminary design? You don't have to mention who they are, but difficult questions. If it's very different, the question is, why does SANRAL waste their money on a preliminary design? Why don't you just go to final design?
I doubt there would have been any deviations from what the consulting have looked at the prelim designs. Yeah, but I don't think there would have been any deviations. If there were, those would have been handled accordingly. In construction now, everything is well coordinated. Design is constructible, and any issues that are emanating now, design related to dealing with them as they come.
Okay, Leon would like to know what instructed or what influenced the improvement of the culverts in terms, I think you mentioned, was a 3-cell now 4-cell, for example. Is there an increase in the peak discharge? And considering there was an initial design, was it undersized, or is it just more development in the area and therefore greater runoff, or what is the reasoning for a different culvert configuration?
Yeah, so there's one culvert where we're adding an additional cell, and that was found in hydraulic analysis of the culverts. I believe the road classification changes, so the requirements become a little bit higher, if I remember correctly. Yeah. So that's what governs the hydraulic requirements of that culvert. In terms of extensions, that's governed by the road geometry.
Okay. And then this is I don't really know if this team can answer it, but is the road maintenance more frequent on the Joburg bound carriageway than the Durban bound carriageway? As I understand, larger, heavier trucks are fully loaded going inland as opposed to coming to the port. I'm not sure that's true. load distribute. My suggestion is attend this evening's SAS session, which is all about load on our SANRAL roads, and then you'll get the answer. So how's that for deflecting the question? See, I'm a lecturer. Bruno Cullen, your old buddy from the SANRAL offices. I'm not sure which part of the world you're in, Bruno, but welcome. Visiting sons in New Zealand or Australia, wherever they are, or drinking beer at Midmar Dam, one of the two. How long is Blackborough Road going to be closed due to the demolition and construction of the new suspension bridge? I did ask that question before you all got here, and I was given a very quiet deflection by the contractor. So that's your arch structure, which is a structural steel bridge. You obviously, are you going to build a new bridge and then demolish, or are you going to demolish and people have got to find alternative ways like via New England Road to get where?
The current proposal, and correct me if I'm wrong, the bridge should be constructed adjacent to the existing, and then it'll be jacked into place once the existing is demolished. That time period.
So that will be a whole new site visit when that takes place.
Yes, that will be a video. You'll see all over LinkedIn.
Yeah.
The time period, maybe you can confirm. I'm not sure exact closure period.
Okay, but your challenge, which was explained under accommodation of traffic, is you've got the existing bridge piers. So those piers have got to be removed to give you a wider, the 60-meter deck span. I think you mentioned 60 meter.
Yeah.
How's that going to happen if the bridges alongside is going to be on temporary piers? Or you're going to build, how do you build the new piers when the existing bridge is still there?
So just build the temporary piers first.
Yeah.
And then once you have demolished the bridge, then you're able to build the permanent because of that interaction.
So is the road going to be deviated across the temporary structure? I mean, the structure in its temporary position.
So the road will be closed for about 12 weeks. It's a 3-month.
There we are, Bruno. Buy another house.
Unfortunately, that has to be closed due to the nature of how that bridge is. We have done several alternative looks at how to minimize and to minimize the road user impact. And that's, I think, as tight as we've currently got it. We are looking at how to better resource it as well to even further minimize. But the contractor is well aware in terms of the impacts. I think there's 2 petrol stations there. It's a main artery road. So that's a special case there.
Okay, so 12 weeks and penalty clauses of $1 million per day over the 12-week period, or?
It's very small in writing. I must look for it.
Yeah.
Complaining residents are much worse than penalties, so they'll only deal with a lot of that.
Yes, definitely.
Okay, let's go up. Gift has given you lots of input on potholes. Are no longer potholes, they're craters, sinkholes. Okay, then Given has suggested, in terms of your subbies or your CPG contractors, what sort of due diligence do you go through in terms of making sure that they don't negatively impact the job in terms of quality and time? The general public view is this project's behind schedule. Is that unfair, or realistically it is because of you've had how many 93% of rain?
So
is that the only reason for delays, or is it?
Yes, that's the whole piece.
That's not accurate.
Yeah. So in terms, just to go back to the former question, the CPG process is quite strict. In terms of vetting. There's a whole ranks of due diligence processes that Kevin and his 50-man team go through. And then once the team is on the job, you've been awarded the job through the relevant processes and you're now approved, you've won the award and you're on the job, there's a set of what we call TE supervisors. So senior TE supervisor and a whole string of TE supervisors who are actually site engineers from the contractor. And their specific job there is to help implement, document, control all aspects of that subcontractor. They take it upon themselves that this subcontractor is actually my company. And that's the approach, and that's what we teach on this project. This subcontractor belongs to me. I'm partial owner here, not getting any funds or anything, but I'm a freebie to them, and now we need to execute the job. And that process, I think, is fairly in depth. It's fairly in depth. And that's how we vet that for that bid.
Okay, then I'm not sure if this question's relevant to the site, but Gift wants to know why is it that buses are capsizing or overturning down embankments where they are, or why is the guardrail being used as opposed to concrete New Jersey barriers? I don't know if that's a general question or you've not had any bus incidents on this section of the route. Okay, then just from my perspective, why go for CRCP? Not a flexible bituminous, flexible base course. I made the decision to go for continuous reinforced concrete pavement. And is the base major section where you stop and they start also CRCP? Through to,
Yeah.
so all the way up to Lion Park is concrete with the premix.
Yes.
Overlay. Hopefully you're going to get a better premix finish than Rumdale are getting on their section at the moment.
Sure.
With some smooth patches, they're going to have to.
We all think the contractor is learning.
Yeah. Yeah. So what was the decision? Is it load related? Is it?
So that also played a role, but largely due to loads from the lentils.
Pavement life, what is the design pavement life on the road? 20 years. Because concrete pavement's great, but when it starts to fail, ain't so great. We'll be back to accommodation and traffic for 12 months. Okay. Takalani, are you disappearing? Were there any more questions that I've missed? Okay, I think we probably will need to get to site.
Just be careful with it and be able to have a point from that. Currently, we just finished pouring. No. Yes. Well, I first when it comes to it. Okay. Yeah, but yeah. So yeah. Don't know why 50. This was great. Yeah. No, where's Billy? Give me Billy. This one. We to the culvert. I don't know. Tell me what's going on.
Yeah, they just coming with the yes. But the other, there's two mics on there, so the other mic is definitely going through. The other one is just for the everybody else. Yeah.
Let's talk about this one. Tell the guys what's up with it. For me, this is the most important. Yeah. This guy just 101 meters, and then the concrete bridge. So now we have been you know, there was a little bit of temporary soiling that was done. Right? So, yeah. And possibly we made some time, but we managed to work together to ensure that by the time we put it yeah. What the one is
So you can go. We climb on the stairs.
And let's for it side, we're going to construct this a bridge similar as I've mentioned before, 557, similar to this one. There's got 2 piers. So basically, oh, this is our pier 1, bridge 557A. Earlier on, where we're going to construct our MSC wall. It's the northbound. So it's just adjacent to the M3 that is going past Pietermaritzburg, wall number 4. The other wall is about 24 meters. That side, 558, 558, about 24 meters. So these are basically 3 walls that we're going to construct. The other one, that side, we're going to go that side along the field. That's to complete here. The guys are still busy. We don't know if them, but they're busy still. So that the span of the bridge and then the aparting piece just towards the end where we can see guys wearing orange vest. And there's big right, that's where our ramp is. And then next at the bottom there is part of 10.1, which was where that's where our part of an existing short pipe that is going to be located. And some places that the top there, that is our 10.61A. It's about 75. So this one is part of that. Other part that side to the side as we move on. Right, we can move on. Now, I think we are done for the street. I will hand over to Andrews. Going to continue with the. Sorry, guys, difficult to work on top of the stairs, but yeah, I will feel a little bit. It's compressing this all when So there's a lot of companies that are involved. My class is rich as father.
But the live mic is on.
Take a look around. You're going to get a nice view of this. So, it's seriously. I have to say the quality of concrete work in this structure is very good. We had one issue of bulging on one of the walls. That's it. I'm looking forward. With temporary constructions, temporary there's temporary report constructions damaged because a vehicle that was overloaded, and one of the top beams fell on the road. Sure. Nobody got injured, minor damages, but it was rectified within 45 minutes. The road was open, and we had husbands, the subcontractors, the engineers, the temporary work stage on site from Durban within 20 minutes.
Yeah.
He was on site, he inspected everything, signed it off. The road was clear for vehicles. So far, this has been good.
And also mention about the foundations and the challenges that we encounter.
We can stay here the whole day. Those guys up there, you know. So we did blasting on 3 the bases. We lifted one base on that side 1.2 meters, and we lifted the pier with 1 meter, pier 2. So access was a real getting in here. This is very deep excavation. This is a 95-meter deep excavation, and we couldn't file. We had found it on the bed, which we did find. Didn't allow. It was too shallow for file. So now we have to do that as well, because right next to that was done. That was the case. So a lot of things happened. A lot of challenges. But it was good. Basically, we move on to the next. Great, you happy? Looks good, huh? Yeah, temporary staging on this thing. And I think it's kind of look at your left. This is something that happens very often on this road, which is vehicles having flat tires, the breakdowns on the online. Yeah, let's go further to that. Yeah, there's 6 axle drive.
Whole axle.
Combination on site. Normally we have to have 5 and 7 minutes on an issue.
Yeah.
They are very. No, we can't wait. We'll see the post tensioning that's going to be happening over this weekend. They're installing all the things. Tell them all.
It's just a traffic damage.
Yeah. We lost his axle just now. Oh, baby. It's the real time stuff happening in life. We are now on our way to Equip the park. Actually, a very beautiful day. It is also the sidewalk. And well, I'll see you in a couple of minutes at the other one. Getting over here. No, we're going to Equip, we're going down here on the right. Take a walk.
Tom, there's no sound coming from your side.
So once that is done, the road, the alignment is the same, the timing from that button, and once we north and south bound, will run the top. You will enter from the slow line. Where previously we had from costs, that was just minutes. All of it, northbound, carriageway bridge, stops, move your content flow from here currently on the south side across to the north line and build the next. And then that without restricting the contract and building. So that takes time. We think what is the so we're going to go and have a look. Yeah, you can have a look. It's a 63 meter long structure, which has 30 meters straight. And then you have 50. Yeah. And then the whole bridge. I've got a piece to read on the office. But those be the foundations, and they wanted to leave that we don't need. Oh. So we take a look, it's down at the bottom. So the extra portal will be on the right hand side. You see we've got our old train to rock. We always have but the rock on this side is definitely about 300 meters below, so it should be fine. And that rock pull is going to end up here, and we're going to put the gable. Oh, yeah, sorted. When that's what's broken down, yeah, they just put it design. So yeah, we're gonna this actually gonna look very good. On the critical part, is but the one that is this can see that a flow that is safe from that part is as you can see from that part here at here is more critical than what is on that part. Increasing the waterway area so that you don't have yeah, well, this, did you drive this? Yeah, yeah, we drove this. It was always, I thought there was almost the king. Became definitely was an urban drive. You see that they broke it down. See, they broke it down. And it was nothing, but the damn cruise was didn't go wrong. It was lots of long time. And it was also a temporary measure because where you're on the they've been there for a long time. I mean, corrosion on the steel was worse. But you can see on the movement of the deck that parapets starting to break, pieces were breaking up. So it was the correct answer. So in the road up on the so we move on to the next one. Right, we're moving on to the next one. Blackborough Road, as it is known as. Left-hand side, for those of you who know Maritzburg, is the UKZ in agricultural factory. HVAC. Ipworth girls, it's not co-ed junior school, but high school girls private school. So the tennis fans, you may remember there was Liz Gordon doubles at Wimbledon. She used to live on this house in the corner. Is this intersection behind us that rounded up?
Correct. And then this is Blackborough. So because Hudson was closed, Sandal then engaged with stakeholders and go to the temporary on-ramp from Cleland to the end town. Thank you for that.
The temporary detour that you signposted, you go on there on that ramp, you get onto the.
Correct. Once the project is completed. Yes.
Turn on access to the new office. One of the biggest challenges here is you are effectively building right in the middle of the city. And tolerance levels by citizens in town who've always gone route A, B, or C is not perhaps what it should be when it comes to being disrupted to the travel patterns.
Yeah, the road user impact is something both the consultants and the contractors should be heavily vigilant, cognizant of. Guys also create their own shortcuts through urban areas. They're not close. So we're going to come up now to the clean and fresh market of the clean and fresh.
M&A, Head's office, Council Norris Blue and Associates office. No.
Oh, let's do a roll. And get out of this.
Right, so we are now at what they call the Cleland Road Bridge, which was one of the first structures that they built. And behind us, we've just come along Cleland Road, which is the road that goes past the Pick n Pay shopping centre, Hayfield shopping centre. The proposed SANRAL new regional offices will be to the back behind Mokasa Norris Muller and Associates offices, which is the building on the background. And obviously Cleland Road will go under this bridge, which effectively brings traffic via the M3 into Allen Patton Drive in order to get to Hayfield. That bridge ahead of us will go around in a long loop, come back round and join at that intersection. That is behind us because of the reach that shaped off and this is where the mechanic wall is being constructed over here.
All right, so we are now on the Cleland Road. It is really interesting. We're leaving it as we have on the point. I want to down only one entry and 10 following. Yeah. 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 So I'm glad Carsten is not here because of right. In any case, construction just was very, I wouldn't say challenging. It's the first bridge that we did this project. So founding it, getting the geotechnical engineers involved, and founding it on proper material. Larger challenge. In the case that the geotechnical investigation is initially that was actually on the ground a couple of meters different. So that made the complex fishes on how far do we have to go down? It's a big pile everything. But we just we had to geotechnical and we investigated everybody and we found it, all of them on rock. The first one,
one of them is Paul.
yeah, we got the Bakken peg on the wing. File, the 39. And we did the OTEC file, which is to 80 tons. That's an awesome sight to see. So we did that over it and then they have file changing tap on it. Fast to find color. The section was 3 millimeters. Yeah, so we found it in good material. We did the course as well. We did the course on the files. We got the contact from concrete to rocks. With regard to affected building that construction time, delays, rain was the major factor. Rain was the one thing that stopped them most of it. And the drainage schedules and the way that they manage stormwater was good. Oh, definitely. Once the roadworks are done, definitely. Yes, everything. It's part of my road. The road goes, I think, for my other side. So this will be all cleaned up. And
Is the plan to reinstate and reopen Cleland Road before the road over the top, or is it going to be it like this until everything to be open? It has to be open before. So the way that we did is that the description of the package on the screen. Oh, it's so nice.
Okay, I'm proud of it. I think you did a good job on that. So this is definitely. Oh, I should have put his name on there. I didn't. We didn't have so many issues on this design. Right? How many times did we hassle on this one? Oh, like that. Oh. So if you can take a look, the concrete's not bad one. This is offshot. This is good. This is nice. Apart from the, we have to leave that open
So you're going to get a little bit of rust, but they'll clean that off unless that rebar there can get it. But that can happen.
This deck is actually tied into the. It was designed to be tied into the buttons with no bearings or maintenance.
Yes. So it's got a 12 millimeter Teflon bearing that spans the whole abutment in both ends. The whole thing monolithic cast.
The tie-in hasn't happened yet, so it can shrink. It's potentially.
Shrinking of the deck, so that's and always happening as we go on. You can see if you look at the parapets, you see people casting up. Contractor did a good job. Always is nice for me if you stand under the bridge. Get the magnitude of this structure that will never be noticed by people driving on top. Or under. You just drive past. You're going to see the embankment spill throughs, and that's what you're going to see. Don't see anything else.
It's a good shame.
Which is a very big shame. I mean, if this could be, you can take this piece of the video and then have a board up next to the bridge, letting it play and roll over. Click here. Each time you roll over it, it's a different picture. Yeah, we had lots of issues getting the patterns right. The pattern is very important. Most part of the bridge. And you shouldn't look left and you won't see the crack. Wait, no. No, there's no crack. Yes, completely. So that's a particular color. Was the so that's the new color. I still need to do a small thing, so just need to carry on with my part. I've asked him to take some of the different over so I can just improve this. However, that column is complete, and we should be signing it in the next week. Quality relocation of services. Relocation was done. We had a major relocation of a service. If we can move this one, to show you, there's a sewer line that ran underneath the footing of the retaining wall, which is on the left. If you take a picture, this is always a nice thing to go through the structure into another. So we had a sewer line that ran underneath. So we had to relocate it on this side to the inside.
That's going to be one seriously high wall, because if you look where it is,
Yeah.
you're going to get up to the deck.
Well, the wall's not coming all the way. It's stopping the shot, but we're going to have to pull up.
But is the embankment going to be battered down to the?
Yes. So you're going to have two full tops. You can have. What's nice about this? Yes, you have a. You have a. You have an engineered pull on the one side, and then to take up the rest of the road, you have a normal. Then just nice.
So how does the effect of the approach frame? Oh, thanks. Pull through. So the batter comes from the end wall underneath the deck, and those piers pop out to the top.
You have an open slab that goes out. Then also we are looking at different ways of treating the crossing. Was obviously the option because we've got a big site there. So we definitely be in but for that section that's top of the bridge, we go spill some stars. Normally we have something going on. So
but you shouldn't see those columns. You'll never see those columns.
Those columns
be in the embankment.
Yeah, you'll see 300-400.
Yeah, you'll see half of the big bearings.
Yeah.
That's it.
Yeah, that's it. The same one. And then when we poured the deck, this was actually interesting for it because everything flowed down to the north. This is the bi-directional. Correct. That's why that's
Going into Cleveland Road, it goes to that intersection that's under construction.
Come from there to come this way onto the on-ramp, onto the or to go to market and via the diverging path. But this was very necessary because there was no real accident. So this had to go all the way back to Ellen. You want to see good construction? Go closer. Where's that thing? What you got? You're not on the mic. Yeah. Oh, you mean you follow the pattern? Yeah. Yeah. Hindsight. All right. Yeah. So we've covered. There's a culvert. Culvert 0731, which is complete. This is the bridge. That's the.
Stand on that side.
Yeah, let's go closer. I can find some of the images as well. John. John. Hey, John. Mr. LinkedIn, we can take a photo. Yeah. Mr. LinkedIn. And then come back. Good. Why are you doing baby. You are married to this. You live, eat, and sleep with. Yeah. So keep this thing close to you and explain. Talk to the people about what this is happening. Your baby. This is your baby.
Okay, I'm doing an MSc wall, which is a mechanical stabilized wall.
I need to be in the picture. If we don't want someone as famous as you, okay.
Okay. This is the MSc wall, which is a mechanically stabilized wall.
Yeah. What's your productions like? What you get on a daily basis?
So what's happening here? We are stabilizing the fill using a polymer reinforced straps, which is known as parawebs from McKune. So we are the purpose of this wall is to prevent the fill impediment from moving to the river. So as you can see, the wall starts and stops before the bridge. It doesn't connect to the bridge because the sooner we get to the bridge, the wider the wall. So yeah, we've got panels. These walls are built on panels that are actually placed together, but each panel there's a gap between each panel. So each panel is independent. It doesn't depend on the other panel. It's like it's what you call one unit. For each and every panel you put, there are 4 to 6 straps. So those straps are actually holding the panel together and holding the fill together. So the whole idea of the mechanical stabilized is to prevent failure like sliding and yeah. So far, I still have 8 to 9 meters to go to connect to the deck, to the top of the fill. Yeah, to see the wall properly, you have to come inside and yeah, have a look.
Where do we make these panels?
They were manufactured here on site by one of our subcontractors. So mostly it was local subcontractors. And also we're using one of our subcontractors to save them.
So in terms of material, we are using 87 material, which changes from 57. So yeah, we're using a good material for the wall. So far, here I still have 11 meters to go. And towards the end, okay, I'm a Farawak Lafon. I'm a Farawak. I'll tell you one, the Pumbabuni. Okay. All its length is 180 meters. Okay, there you can look at the actual wall that me because I'm not trying to. I was doing this whole wall.
How many panels high you're going up with?
There I still have 6 panels. They are at the end. So the whole idea is to start from the bottom and go up. Always one level, one level, one level, but at the end.
So you do a complete length.
Yeah, complete length or complete level. For example, if it's going like slope is going down, we start here going like this, going like this, going like up
Until you catch that
you
point.
catch the point. Then you go, then you stop that side because you already achieved the higher.
Right.
Then you go up, going
Up one level. Correct.
You can see this is one level. Moving from here, all of this, we are on 2 there.
Yeah.
We might be on 6 there.
Yeah. And then all of this has subsoil drainage.
Yeah, it's subsoil drainage. You can see there is a whip holes there. They drain the water out from there. We have subsoil drainage side, but also the thin drain, the other side.
Oh, okay.
Connecting the field. This is more of the engineering field, stabilized field, and the normal field connecting the field. Oh yeah, also the water having such a beauty. Having people. Yeah.
So this is the only time that the people will get to see this wall.
Yeah, that's all. But otherwise, after closing here, you won't see.
You're not going to see this
because there's a river here, there is a bush here, so yeah. Okay. So each and every unit, every panel, the unit on its own. You can see there's a gap between. You can see there's a gap between this panel. There's a gap between this panel and the panel. It doesn't really. There's a 20 meter between the two, and also between this and this, there's a gap. There's a gap. So each and every panel here, it's its own unit. It's independent of the other one. So this one doesn't add any load to this one. This one doesn't add any load on this one. This one doesn't add any load to the bottom one.
And each panel is strapped into.
It's strapped in. The straps is holded by straps.
And then the material holder.
The material holder. So depending on the friction between the straps and the material. So you have to get your compaction right in order. Yeah. Okay, let's go like this and yeah. Because we can go at the bottom because this one is too muddy this side.
Okay.
Or maybe
Have to.
Okay. Anyway, let's go.
Let's have a look at the top. When was this wall started? When did you start?
I started this wall on October.
October.
Yeah, October this year. So, but I had a bit of challenge with the rain, Maritzburg rain.
Yeah.
But yeah, it's like 3 months old now.
Mm.
So if it was no rain and out of production, it could have been close to completion. This was that we're using parawebs, the one that are holding the whole together. So these are connected here and tied in that side. So when you compact on them, they hold each panel together, like each connecting the F and the panels. The second here. You can see here. That's one second. This is holding this wall. You can try to tension this one. Try to tension it, and you can see how hard is it? Like it's holding it together, not to go. You can't even move it. You can't even. You see, this wall is depending. This one is depending on this 2, 3, 4, 5, holding it from moving vertical up and down.
So the material that it's designed to hold back is actually holding itself.
Yeah.
Preventing itself from actually.
From falling. So it prevents this one. This one can be. These panels they don't have much purpose rather than erosion.
Yeah.
Like
it's basically a shutter.
But otherwise, the whole idea of the mechanical stabilization is the friction between this paraweb and the material. So we can come and cut these things on. The wall will still stand.
Yeah.
It will be a vertical wall, but the problem will be when
There's
it
nothing
rains,
to hold the material.
When it rains, it's gonna dry. It's gonna take out the material will hold itself because of this reinforce. But the rain and other factors will come and chow it, then it's gonna end up collapsing. Yeah.
So it gets strapped from there.
Yeah,
across.
It's tied in there.
Okay. So it loops.
Yeah, it loops that side going vertically 2%, because in order to if it was going at this side, it was gonna slide back that way. So basically, when it's going at 2% like this, it's holding this, pushing it like this, holding each and every panel at the same time, holding the F here. So it's a mechanism between friction of this and
gravity.
Gravity, yeah. So each and every panel is independent of the other one. So if one day this one fails, goes out, the next one here will just stand there.
Really? Yeah.
Yeah, because the panels are holding the panel together, are holding it like this. So if this one fails and go out, just gonna be an empty slot there. That panel, that one has failed. This one won't go down because it's been held by the
straps.
So each and every panel varies. Like for example, it is a design for each and every panel. Not always. For example, this one has four loops. This one has 6. That might have 6. That one has 12. So it depends on the pressure that the thing is gonna exert and the height of the way it's gonna go.
Right. What's the difference between these hooks?
There's no difference.
And
the other one, there's no difference. Just that these ones are still loops, and these ones are plastic or polymer loops. So basically, this one, because the material, this ones we get it from India, so it's hard to get them. So in general, we just use this if we are still waiting for those ones.
Okay.
These ones are still loops. We use a steel rebar. It serves the same purpose.
Those are just galvanized bars.
It must be a galvanized bar, because once the bar erodes, for example, let's say it's holding this panel,
it rusts and it can break.
This will slip, the panel will go.
Correct. Yeah. Okay. So that's one of the benefits of having these. It does not. It won't rust.
This is the bar. Goes in here.
Oh, okay.
So the panel
gets tied across.
Set up here. If you use any bar like this, you can, then once this one runs, the panel will go. So the
Okay.
wall will start fading. Okay. So the advantage of this is cheaper and it serves the people. This is the actual applied by the Macaferi, the paraweb, the one roll of paraweb.
Okay.
It's 120 meters. So for example, it can go from here, you go up, it's like 8 meter, come back, 8 meter, 8 meter, 8 meter. So it's like 1, 2, 3, 4, 5, 6. So the one panel will hold 60 meters of this.
One panel.
Yeah.
Sure. And how much is the roll again?
It's 120 meters.
So two
rolls,
two panels.
2 panels, yeah.
One roll, two panels.
One roll, 2 panels, at most.
Sure.
They're not that equal to. Yeah. So we here we have laid the rolls and we have
Compacted.
I know we have not compacted,
Oh,
we
not.
just placed the material for now. So because of everyone went to lunch now, we're gonna compact.
Okay.
Yeah. Working for us.
Yeah. So before the straps are in,
Yeah.
I see you got some sort of bracing here. That bracing
okay.
is basically what holds the panel in place.
Yeah, the bracing is the one that holds so the panels in place. So we also have a beading in here. This beading prevents any fines from moving
Through the gaps.
Through the gaps. So we don't have any ingress or any
Yeah.
fine ingress. So the thing will be left mostly stabilized. So the mechanism is just friction and gravity.
Gravity. Very well. Huh? That's how to move.
Hey, this friend is freshman.
You got a mark.
Yeah.
That's it.
Okay. All right. So I see everybody downstairs wanting to go, but I mean, this is actually what it's about. This is where you're going to drive on. This is what you want to see at the end of the day. So it's a complete bridge with your parapets, drivable surface. Still needs a little bit of work on the top of the parapets. If you can stand here, you can see the bridge is sloping down quite a bit to the left, which is going to. Myself and Craig just discussed it about the water flow. that's going to happen at the corner there, at the bottom left. So that's going to be a challenge because you're going to have a lot of water coming down all the way from the top.
Yeah.
And it's going to accumulate, and it's going to develop speed. Then it might jump. So it's not a normal downshoot that you put in at the bottom. It has to be designed. So that's going to be a challenge.
Yeah.
So yeah. But other than that, we looked at the shrinkage of the deck. We looked at the cracks in the deck, which is normal. There's not. I mean, if you just go closer, this area you won't see anything, which is actually bloody good. But yeah, this is B0559 at Third Bridge. Yeah, we've done it. There you can get a good view of Power Line 731, which is completed, and we're starting the backfilling against it. We'll be completing that in the other 2 stars and then next week. We'll start filling. And then we have to do the whole Cleveland Road. Then that's about it.
One of the things that we discussed was the diversion of the sewer pipes.
Oh, I did.
Yeah, I've already done that.
Yeah, I did.
Yeah. Story for another day.
Okay. Go. Right. So then, yeah. So
quite asleep today, huh?
Quite asleep. When you walk up, you could feel.
Yeah.
The legs are doing. Yeah. There's not much going on at lunchtime. It's pay weekend, so not much will be happening also at the moment. Yeah, you can maybe do a last shout out at the top of this. Keep your camera up. I see a 360 of just about all the structures. All the 731, 1021, 1021 that side. You're going ramp C, going to Market Road 0557A and 7B. Turning to the right. You see Market Road, the rest of Cleveland Road. Then on the right hand side, so we finish off the MSU wall 3. And that's it. From side, that's a wrap, I suppose.
No,
see in the office.
Yeah.
Now you might hear what they're going to say next week about this presentation going on so long. Still recording? Yeah. Slippery. Okay.
It is.
Something. The mic wasn't able to hear you.
Yeah, no, take it. Here's the check.
No, I don't want to.
Oh.
One of safety is a priority on site, and as you can see, that's what is safe to use. Number 1, safety first.
H1 structures, who are
subcontractor?
They're the subcontractors. Okay. So what were they involved in doing?
They're involved in construction of all the bridges.
Okay.
So there's a component for bridges,
and
culverts,
medium barriers, all the concrete work that they're doing, just all the major.
All the major.
Yeah. Then the major culverts, there are other subcontractors, Fulek and Poco.
Okay.
Yeah.
Okay, right. Right. Enjoy your long weekend, eh? Go home now, we're finished.
No more for some. What's
You on?
So I just thought I'd the last word.
Say hi, say hi, say hi. Hey, what's up, everyone?
TK. We're handing over to you.
Takalani, you need to come and do a rap with a branch.
You can do it, yeah?
But we're just going to hand you over to Takalani Njapali from the Maritzburg branch, who's going to just say the last few words, and then we will wrap the day up. Thanks for joining us, everybody.
Thank you very much for that, Tom. First of all, I'd like to say thank you to the WSP team, the engineering team, and everyone that was a part of the session. We also want to thank Tractor, Grinaker, and all of those that are involved in this project. We were able to get some great insights on how the project is doing and how well it's progressing. For those that are within Pietermaritzburg area, don't be stressed and angry. The work is actually quite good, and at the end of it, we'll have a fully functional road that will be able to serve everyone in the community. Thank you again to all the attendees. I think we had about 400 plus attendees. Thank you for registering and attending. And we really hope that you can also bring additional projects to the forefront. Any project, whether it's in KZN or all of South Africa, please do send in your information. It'll be great for us to also have a chance to do a virtual site visit. So from us, SAICE Pietermaritzburg Committee, we'd also like to thank Adam. So Adam is behind the camera. Thank you for availing yourself and for also making this a lovely experience. Thank you again, and please make sure that you enroll for other webinars and sessions that SAICE shares. Thank you.
Cheryl Lee, if you can switch off the recording for me if you're still there.
Yes, Tom, I'll do.
Okay. Just stop the recording if you don't mind, and everybody that's in can start to leave. The CPD time is up in any case, and you should get your certificates